Welcome. Today, we're diving into the practical world of integrating AI into Spring Boot applications. If you've ever watched a quick demo where someone adds a chatbot to a backend in minutes, you know it looks impressive. But the reality is, bringing AI into a real Spring Boot app with actual users, production traffic, and all the complexities of logging, retries, and costs is a whole different challenge. This video is about bridging that gap, moving from toy examples to robust, production-ready AI integrations that won't come back to haunt you later. It's easy to get caught up in the hype around AI. Many tutorials show simple integrations, but they rarely address the real-world challenges developers face. In production, AI isn't just a plug-and-play feature. It needs to fit into your backend architecture in a way that's sustainable and maintainable. We'll focus on how AI can be a valuable addition to your Spring Boot backend, not just a flashy add-on. As a backend engineer, you probably think in layers, controller, service, repository. You care about reliability and don't trust black boxes blindly, especially after being burned by magic solutions in the past. Now AI comes along, promising intelligence with just a prompt. But there's no strict contract, responses are unpredictable, and debugging can be a nightmare. Most tutorials ignore these realities, but they're crucial for real-world applications. Let's clarify where AI should actually fit in your Spring Boot application. AI is not your core business logic. Instead, think of it as a capability layer, similar to how you use search engines like Elasticsearch, messaging systems like Kafka, or caching with Redis. You don't let these tools take over your architecture, you integrate them carefully. The same goes for AI. AI shines in certain scenarios. It's great for content generation. Think emails, summaries, and reports. It can power natural language search, extract data from text, and enhance internal tools like support assistants and dashboards. These are areas where AI can add real value without risking the integrity of your core business logic. On the flip side, avoid using AI for critical business decisions, financial calculations, or anything requiring strict correctness. If your system depends on AI being 100% accurate, it's already on shaky ground. AI is probabilistic by nature, so it's best reserved for tasks where occasional errors are acceptable and won't cause major issues. A common mistake is calling AI directly from your controller. It might look clean in code, but it's a maintenance nightmare. Instead, treat AI as an external dependency. By separating AI calls into their own service layer, you gain flexibility to change providers, add retries, log requests, track costs, and implement fallback logic, all essential for robust applications. By moving AI calls into a dedicated service, you can manage dependencies more effectively. This approach allows you to swap out AI providers, add logging, and handle errors gracefully. It also makes your codebase cleaner and easier to test, which becomes critical as your application grows and evolves. Prompt engineering is now part of your backend logic. It's not just about writing Java code anymore. How you construct prompts directly impacts the accuracy, tone, length, and cost of AI responses. Small changes in prompts can lead to big differences in output, so treat your prompts with the same care as your code. Just like your code, prompts should be versioned, tested, and refined over time. This helps maintain output quality and makes it easier to track changes when something goes wrong. If a product manager asks why responses changed, you'll have a clear history to investigate. Treating prompts as first-class citizens in your development process is essential for long-term success. AI APIs behave more like flaky external services than clean libraries. You'll encounter timeouts, rate limits, partial responses, and random delays. So, treat AI like any other unreliable network dependency. Add timeouts, retries, and fallback logic to ensure your application remains resilient, even when the AI service is having a bad day. When calling AI services, always set a timeout. This prevents your application from hanging indefinitely if the AI provider is slow or unresponsive. For example, using Web Client in Spring Boot, you can set a timeout of just a few seconds to keep your system responsive and protect your users from long waits. Retries can help recover from transient errors, but be careful. They can also multiply your costs if not managed properly. Always be intentional with retries and consider the financial impact of each additional request. Sometimes, a simple fallback message is better than repeated attempts. Adding fallback logic is essential for user experience. If the AI service fails, return a friendly message instead of an error. It's not glamorous, but it keeps your application reliable and your users happy, even when things go wrong behind the scenes. AI isn't free. Every request costs money, and costs scale with usage. More tokens mean higher bills. That just one more feature can quietly increase your expenses. It's important to monitor and control costs from the start, especially as your user base grows. To keep costs in check, limit response sizes, avoid unnecessary context, cache common responses, and log usage per request. For example, logging the number of tokens used per user helps you track and optimize spending. These strategies become crucial as your product scales. Debugging AI is different from traditional code. You can't step debug an AI response, so logging becomes your best tool. Log input prompts, output responses, and time taken for each call. Just be careful with sensitive data. Never log anything you wouldn't want exposed. Testing AI features can be tricky because outputs vary. Instead of checking for exact text, validate the structure of responses. Mock AI responses in your tests to keep service logic testable. This approach ensures your application remains robust, even as AI models evolve. Everything works fine for small apps, but as traffic grows, new challenges emerge. Latency increases, costs spike, and users expect consistency. At this point, you need to think about async processing, queues, caching layers, and rate limiting per user. AI integration becomes a system design problem, not just a feature. To handle increased traffic and maintain performance, implement asynchronous processing and message queues like Kafka or RabbitMQ. These tools help distribute workloads, reduce latency, and keep your application responsive, even under heavy load. Caching is another key strategy for scaling AI features. By caching common responses, you can reduce the number of AI calls, lower costs, and improve response times. Tools like Redis make it easy to add a caching layer to your Spring Boot application. As your user base grows, rate limiting becomes essential. By limiting the number of AI requests per user, you can prevent abuse, control costs, and ensure fair access for everyone. Implementing rate limiting protects both your system and your budget. In production, AI responses will occasionally be wrong, and users may trust them anyway. Product teams will push for more AI features, debugging will feel unfamiliar, and costs can creep up silently. Despite these challenges, AI can remove a massive amount of manual work if used with control and discipline. The key to successful AI integration is control, not blind trust. Set boundaries, safeguards, and maintain discipline in how you use AI. Treat it like any other external system, and it will become a powerful tool in your backend arsenal. Integrating AI means introducing a probabilistic system into a deterministic architecture. This changes how you design services, testing, logging, cost control, and failure handling. Embrace this shift and adapt your engineering practices accordingly. With AI in the mix, service design must account for non-deterministic responses. Build in mechanisms for error handling, retries, and fallbacks. Ensure your services can gracefully handle the unpredictability that comes with AI-powered features. Testing AI features requires a new mindset. Focus on validating the structure and intent of responses, not exact matches. Use mocks and stubs to simulate AI behavior in your tests, ensuring your application remains robust as models change. Effective logging is crucial for AI features. Log every prompt, response, and timing detail, but always be mindful of privacy and sensitive information. Good logs are invaluable when debugging unexpected AI behavior in production. Put cost control into practice by setting usage limits, monitoring token consumption, and reviewing logs regularly. Proactive cost management helps prevent surprises and keeps your project sustainable as it grows. Failures are inevitable when dealing with external AI services. Always provide meaningful fallback responses and ensure your application can recover smoothly. This approach keeps your users happy and your system reliable, even when things go wrong. Monitoring is essential for understanding how AI features are used and where improvements are needed. Track usage patterns, response times, and error rates to optimize both performance and cost. This data-driven approach ensures your AI integration remains effective over time. As users interact with AI-powered features, they come to expect consistency. Meeting these expectations requires careful design, thorough testing, and ongoing monitoring. Strive for predictable behavior, even when the underlying AI is probabilistic. Integrating AI introduces new security and privacy considerations. Always sanitize inputs and outputs, avoid logging sensitive data, and comply with relevant regulations. Protecting user data is just as important as delivering smart features. Selecting an AI provider is a strategic decision. Consider factors like reliability, cost, support, and integration complexity. Be prepared to switch providers if your needs change, and design your service layer to make this transition as smooth as possible. AI models and APIs evolve rapidly. Stay up to date with the latest advancements and be ready to adapt your prompts, logic, and integrations. Continuous improvement is key to keeping your AI features relevant and effective. Document your AI integration thoroughly. Share knowledge with your team about prompt engineering, error handling, and cost management. Good documentation ensures everyone is on the same page and can maintain or extend the system effectively. Failures are valuable learning opportunities. Analyze incidents, identify root causes, and refine your architecture to prevent similar issues in the future. A culture of continuous learning and improvement will make your AI integration stronger over time. Successful AI integration requires collaboration across teams, developers, product managers, and operations. Foster open communication and shared responsibility for AI features. This teamwork ensures that challenges are addressed quickly and solutions are sustainable. With AI features, continuous deployment and monitoring are more important than ever. Automate your deployment pipelines, monitor key metrics, and roll back quickly if issues arise. This agility helps you respond to changes and maintain high-quality service. Gather user feedback on AI-powered features and use it to refine prompts, logic, and user experience. Real-world feedback is invaluable for improving accuracy and relevance, ensuring your AI delivers real value. AI introduces ethical considerations, from bias in responses to responsible data usage. Be proactive in identifying and addressing ethical risks. Build transparency and fairness into your AI features to maintain user trust and comply with best practices. Future-proof your AI integration by designing for flexibility. Use abstraction layers, keep dependencies loose, and stay informed about new technologies. This approach makes it easier to adapt as AI evolves and new opportunities arise. To wrap up, integrating AI into Spring Boot is about more than just adding a new endpoint. It requires thoughtful design, robust error handling, cost management, and ongoing monitoring. Treat AI as a powerful but unpredictable tool, and you'll unlock its full potential without sacrificing reliability. Most tutorials stop at "it works." Real engineering begins when things break. By approaching AI with discipline, boundaries, and safeguards, you can build systems that are both innovative and reliable. Remember, AI is a tool, use it wisely, and it will serve you well. Thanks for joining this deep dive into using AI in Spring Boot. With the right strategies, you can integrate AI features that add real value, streamline workflows, and keep your systems robust. Stay curious, keep learning, and approach every new challenge with a practical mindset. Happy coding!